Hi there, I'm Robin, and in this video I would like to discuss my first impressions of the Dobot Magician. 2 weeks ago I took delivery of the Dobot and I've used it for a couple of hours for some pick and place and drawing exercises. I ordered the advanced educational plan version of the Dobot, which is the most complete package. The basic model comes supplied with a suction cup, a gripper, a drawing kit, a 3D printing kit and a Bluetooth module. And in addition to that, the educational plan includes a laser engraving module, a Wi-Fi module, and a game controller for manually operating the robot arm. First, we'll take a look at the various parts, followed by a couple of simple examples of the drawing and pick-and-place functions. The robot arm itself is clearly designed to appeal to a broader audience than the original Dobot. It has some nicely designed ABS panels. The forearm has several I/O ports and power connectors, which are used for the supplied end effectors, but can also be used for custom applications. The arm itself is made from 6061 aluminum and has a nice anodized black finish. On the sides of the arm, 2 geared stepper motors are fitted to operate the second and third joint. The motor for the first joint is integrated into the base. At the back of the base, more I/O ports can be found, including a communication interface for the Bluetooth, Wi-Fi and USB host modules. Besides a minor alignment issue on the side panels, I'm pleasantly surprised by the build quality and finish of the arm. Also, the end effectors and other parts leave an impression of a well-designed and executed concept. One of the end effectors is a pen holder. It is also made from anodized aluminum and it has a spring-loaded insert, which is used to compensate for writing on surfaces that are not perfectly straight. It also compensates for inaccuracies when setting the pen down position. The pen is fixed using a couple of set screws and can be replaced with any other pen small enough to fit in the holder. The vacuum cup is one of the most versatile end effectors supplied with the Dobot. It can be used for pick and place operations for all sorts of parts, as long as the part has a somewhat flat and smooth top surface. Here you can see the cup mounted to the 4th axis, which is driven by a small servo motor. This is the pneumatic gripper, which can also be used for pick and place operations in situations where the vacuum cup is not suitable for the job. The gripper design makes the jaws open and close in a parallel position, which should make it easier to hold parts in a controlled manner. The gripper is completely made from metal and has LMU bearings and brass bushings for the sliding parts. It is operated by the same air pump as the vacuum cup and also shares the same 4th axis unit. The package also includes a 3D printing head, which seems very similar to an E3D hot end. It works with 1.75mm filament. It is a Bowden style setup, so the stepper motor driving the filament can be separated from the hot end, reducing the weight at the tip of the arm. There is a fan for cooling down the cold side of the hot end, but unfortunately it's missing a PLA fan. The Dobot also comes supplied with a glass plate, which you can simply lay down on the table for printing. All of the connectors are nicely labeled, so you don't have to look for the manual every time you want to change out the end effectors. The Bowden extruder can be placed behind the base to drive the filament through the PTFE tube. I'm quite curious about the print quality, but the 3D print head was not the main reason for purchasing the Dobot, so if it prints well, I'll consider that a bonus. The laser module that comes supplied with the Dobot can be used for engraving paper, wood or similar materials. This is only a 500 milliwatt unit, so cutting materials and engraving metals is not possible. The unit is nicely constructed and has a fan for cooling the laser during operation. It's good to see that a pair of safety glasses was provided, since even lasers with a limited power pose a serious risk. You only have one pair of eyes after all. A couple of breakout boxes are provided with the Dobot, a Bluetooth module, a Wi-Fi module and a USB host module. These units can be connected to a dedicated communication interface on the base of the robot arm. There are several ways of operating the Dobot. One of them is by using the supplied leap motion kit. I'm not sure if this is the most effective way, but it would be very nice for educational use. Another method is by using the game controller. This can be connected to the USB host module with a wireless dongle or a USB cable. The thumbsticks and the buttons can be used to move the arm and activate the effectors. The GameSir controller has a decent build quality and the buttons and thumbsticks have a nice feel to them. Most importantly, it's actually quite intuitive to move the robot arm around this way. The robot arm can be moved manually by moving the joints individually, but also by moving the end effector of the arm in a Cartesian coordinate system. In this mode, inverse kinematics are used to automatically calculate the correct position of the joints. This includes the rotation of the fourth axis, which is very useful. So to get familiar with the Dobot and the software, I started out with a couple of simple training exercises. I borrowed some toys from my kids, since they would make for some nice training material. First, I tried to pick up a couple of blocks and to stack them back up at the new location. The teaching and playback menu can be used for this purpose. When performing a simple pick and place sequence, you can add coordinates and indicate if the end effector needs to be activated. Also, delay times can be set at each point, which are useful when picking up objects with a vacuum cup, since it takes some time for the vacuum to reach a sufficient level. Usually 1 second is enough. You can simply move the arm to each coordinate and add a new waypoint to the list. I use the soft keys in the Dobot Studio and the Teach button to set the points. The Teach button is great to easily move to a new position, while the soft keys are better for fine positioning. To further fine-tune positions, the coordinates can also be changed by typing them in. As you can see, the second stack is not perfectly aligned, but I'm confident that most of this is due to me moving the blocks while teaching the arm and to inaccuracies induced by the vacuum cup. The position repeatability of the arm is much higher than the differences you see here. I think the gripper will be better for accurate positioning, but I'll have to test that later. With the standard settings, the playback speed of the arm is limited to a safe setting. However, both the acceleration and speed can be increased to quite serious levels. In a quick test, I raised the acceleration and feed rate in several steps to 10 times the standard value. As you can see, speed is not really an issue here. Also, I tried to make a couple of drawings using the Write and Draw menu. Using the Insert button, I selected a couple of basic figures. When the figures are in the correct place, you can press the Sync Pose button. This will move the pen to the start position of the figure. This will also allow you to align the paper and set the pen down position. You can do this by moving the pen down until it just touches the paper. Then press the Auto Z and the pen down position is registered. Raise the pen back up, press Start, and that's it. The software is really easy to operate. You don't have to be an engineer to work with the Dobot. The nice thing is that there are several levels of difficulty built into the system. It's very simple to use the system and to get quick results, but for advanced users there are enough challenges. You can program the Dobot manually or make use of the I/O ports. Basically, you can make it as easy or as hard as you want. I've not spent enough time with the Dobot to draw any solid conclusions, but overall I think it's a very well thought out system and a great platform for learning to work with automation, programming, 3D printing, etc. etc. So, no regrets so far. I'm planning to post more videos when I have spent more time with the Dobot. Until then, you can also check out my website uptimefab.com for articles on the Dobot, 3D printing and various other topics. Okay, that's it for now. Thanks for watching.